Yeah, hi, good evening, everyone. Hello, am I audible?
Good evening, sir.
Good evening.
Good
Okay,
evening, sir.
okay. Good evening. So, how was your quiz one exam? So, how many of you have given the quiz one or qualifier? So, any of you have attempt this quiz one or not?
Yes, sir.
Okay, so how was your exam? So, that was easy or what difficulty level you feel?
Sir,
It was easy, sir.
Easy? Okay. Okay, so one or two actually corrections are required in the answer key. Okay, so that in qualifier exam actually there is one re-evaluation, and that term exam, that quiz one exam, we have two re-evaluation. Okay, so that is two answers are not correct, so we are re-evaluating that questions. So okay, any query before starting the session? So have you completed week 5? Because the deadline I think of the week 5 and week 6 will be very close, so you have to complete all the week 5 and week 6 content at the same time. So just try to finish week 5 as early as possible, okay, if you have not done. So now this week is actually belongs to week 6 content. Okay, so week 6 is also released, and this timed assignment is also started. So already 3 days we have released this assignment, so today is the last slot. So if you have not attempt, then please attempt this that timed assignment session. Okay. So though any of you have completed the timed assignments, so how much time you took for the timed assignment one? Can anybody want to share your experience? Anyone of you have done this timed assignment one?
yes, sir.
Okay. So approx how much time you took to complete all four problems? Or you have done in two different slots or like this?
Yes, sir. Two different slots.
Okay, okay, fine. Okay. So any doubt in week 5? Any query? No query? Okay. Then we have already discussed the programming assignment, practice programming assignment, practice theory assignment in last week Saturday. And we have also discussed the summary of week 5 on the Tuesday. So today, if there is no query, then we are moving to the week 6. Okay, so week 6 contents, and we will discuss the topic of week 6. So week 6, we are starting a new topic, and this topic name is pointer. Okay, so any of you have already watched the video, or have you started the week 6? Okay, so let me share my screen. Then we can start the week 6 pointer things. So what is pointer and how we can actually use the pointers? Okay, so one second. How to open this? Okay, first thing, today our topic, week 6 topic is basically pointer. And pointer is basically a variable. So like the other variables which we have already learned till now. Okay, so like the integer variable, float variable, this type of variable, character variables. So this is also a variable, but it contains the address of the another variable. Okay, so this pointer is a variable, but it contains the address of, so suppose this is the memory place for this pointer variable. So this memory place actually contain the address of any other variable memory location. Okay, so suppose we have one variable like integer a, and we have assigned some value like this 10. Okay, so this is normal variable integer. Okay, the type of integer this a, and it contains the value 10 as an integer value. So that means some memory is actually allocated to this a variable. Okay, and that memory can have some address. Okay, so every memory locations have some address. By this address we can actually access our data, if any data is stored at that address. Okay, so each memory location have some address. So suppose for example, this is one memory block, and this memory block is actually assigned to this variable a. Okay, this a, and here in this memory place we have stored this data 10. Okay, so this is actually a data, and the memory address. Okay, so one address is actually contains each memory. So that address, suppose this address is like any integer value, any value we can represent, but in general it is represented by the hexadecimal value or in other representations. So I am just giving one example. Suppose 1002. Okay, this is a address of this memory which is allocated to the a. So now this address we will store in the pointer here. So this 1002. So this is also a memory location, but this memory location may have some different address like 2020. Okay, in the memory. So now this pointer is a variable. That variable actually contain the address of another variable. Okay, so here what we are storing in this memory location, this is a address. This is address of a, of other variable a. Okay, so that is called as a pointer variable. If we are storing normal data like integer, float, that is actually normal variable. But if we want to store the address of some memory location in our memory, then we have to declare the pointer for that. So that pointer variable we have to declare. Okay, so this is the meaning of the pointer. So pointer is just a variable that contains the address of another variable. So this is the definition. Now how we can declare the variable, and so this is the main things required, how we can declare the variables and how we can store the address of that variable. So then we can just play around the code. So so this is the basic structure of the code. Now suppose same things. So I want to just create one integer variable, and that integer variable is initialized with some integer value. Okay, so like this. So int n equal to 10. So this n is a integer variable. Now we want to store the address of this integer variable n. So we have to declare a pointer. Okay, here pointer term we will use because we want to store the address. So what so what type of data actually, so we are planning to store the address, and that address is actually contain which type of data, that integer type of data. Okay, so to declare the pointer variable we have to define the type. So what type of data actually our address will contain. Okay, so the here the address of we want to store the address of n. Okay, and that n is actually contain the integer data. So here we have to define these things for the pointer variable. So int. Okay, so that means this pointer is pointing to a address. That address contain actually integer data. Okay, because of that we are writing here integer. Okay, and here this is the identification of pointer. So this is a pointer variable p, asterisk we use to represent as a pointer. And after that, so okay, so we want to read the address of variable n. So how we can read the address of variable n? So we will write like this. We will write the n symbol. Okay, n symbol before the variable n. So if we write this, so what happened here when we are writing this and symbol before n, so actually it is reading the address of n, and that address is assigning to p. Okay, that address is stored at the location of p. Now if we want to print this address, so how we can print? So simply we can write the print statement, print f, and we can write like percentile x. Okay, so x is basically represent as a hexadecimal value. So generally we represent this pointer as a hexadecimal, or we can also print it as an integer, so there is no problem. And we will write like this p. Okay, so when we print like this, so you can see, now we run this code. Okay, so we are getting one hexadecimal value here, unsigned int. Okay, so integer st. Okay, so you can see we are getting this hexadecimal, and we can also see if we print the direct address of the variable like this. So end, this end symbol and n. Okay, so this is also a representing a address of n. So let's run. Okay, so we will use the slash n. Okay, now you can see we are getting the same address in the code. Okay, now you can see we are getting the same address for the both things. So p is also contain the same value, and this n symbol n is representing the address of n. So this is called as a pointer. So in general, when we are writing the code, so regarding the function thing, so
That output is the address of n.
yes. So here output is, so both print statement is actually printing the address of n.
Okay, sir.
Okay. So now the p line is actually contain the address. So we have already assigned the address of n into the pointer p. Okay. So because of that, this here we are printing the pointer value. So what pointer value we have? So that is actually address of n, and here we are directly printing the address of n. Okay, so if you want to read the address of any variable, just use this and symbol before that variable, so that will actually return a address of that variable. Okay, now you can use this pointer to just use access your data also. Okay, so here actually when we are printing this p, so this address is printing. Okay, so how we can access the data using the pointer now? So to print the data using the pointers, because pointer is also pointing to the memory location. So what happened? Actually, this variable. So here we have declared this p variable. Okay, and this p variable actually contain the address, and that address is actually a memory location of n. Okay, and that is actually contain the 10. So can we access this p using the p, this direct value 10? How we can access this value 10 using this p value directly? Okay, so to access the value using the pointer, so what we can do, we can simply write the print statement like this. So print f, okay, so percentile d, and now this time I'm writing this asterisk p. Okay, when I print this, so okay, let's use the new character line. Okay. Now you can see we are getting 10. So what is this? Actually, this is a dereferencing. What we are doing here, so this is the declaration of the pointer. At the time of declaration of the pointer, we use this asterisk before the variable name p. Okay, so at the time of declaration only we use this asterisk before p, and we assign the address to that this is the initialization. Okay, basically this is the initialization. Or we can if we want to initialize the value later, so what we can do, we can also write like this. So p equal to this. So the previous statement is actually equivalent to this code. So the previous line which I have updated now, so that is actually equivalent to this two lines. So this is just a declaration of pointer p. Okay, and after that we are initializing the address to this p. So this is the initialization part. If we want to directly initialize the address, so we can directly write this p equal to at the this end symbol and n. Okay, so now the address of the n will be assigned to this p. But if we want to read the data at that address which is stored in the pointer, so we have to use the dereferencing. So dereferencing means if we want to access the data, then we can use this asterisk symbol before p. So now this time we are not declaring the pointer. Okay, this time we are just printing, or we are using this pointer variable. So at this time, if we are using this asterisk symbol before p, so this is actually a dereferencing operation. So dereferencing means we are just accessing the data at that address. So here you will get the data 10, okay, which is stored the at the address which is stored inside the p. Okay, so you can directly store the you can directly access the data also using the pointer, using this dereferencing operation. Okay, and you can also change the value of n. Okay, so you know that this pointer is pointing to the same memory location of n. So if you change the data through the pointer, that will also be reflected to the n variable. Okay, so suppose what we are doing, so I am just assigning the value p equal to 20. Okay, so in next line what I am doing, so I am just assigning a data. So this is the data assignment operation. Okay, this is not a this 20 is not a address here. So when I am writing this asterisk p, so that means I am pointing to the memory location. Okay, I'm pointing to the memory location and assigning the new data at that location. Okay, so that means in the previous, the value at that address of p was the 10. Now I have changed this p equal to 20. So I am updating the value at the address of p. So that p value, this 20 will be assigned to at this location. So like this operation is looking like this. So if I am writing this asterisk p equal to 20, so the update is happening at this place. Okay, so this 10 will be replaced by 20. Okay, and our n is also pointing to the same memory location. So if you access through this memory location using the n variable, then that value will be reflected to the n also. So let's just print again. Okay, slash n. So this is the previous operation. Now I have updated this. So now let's print again this pointer value. Okay, so using the pointer I'm accessing the data, and I can also print using the n variable. So I'm just trying to print the n variable. Okay, so like this simple n variable, and this is p. Now you can see, so this was the previous data. Okay, this is memory locations, and then 10 value was stored at this n equal to 10, and we have also assigned it to the pointer equal to 10. But when we change this value at the pointer, you can see now 20 is also printing at the same address which is pointed by the pointer, and also n is also updated. Okay, the variable n value is also updated because the and this variable n is also pointing to the same memory location. Okay, so if we are updating the data at the same memory location, so that will be reflected by variable also, normal variable. So that means we are directly accessing the data through the memory address, and we can also update the data using the memory address, and that will be reflect to the variable. So this operation we can do using this pointer. We can directly access the variable, or we can perform some operation. So like one example, so in normal function, so is this clear? Any doubt in this? So I'll remove this. After that, if any doubt in this, so you can ask.
No, sir.
Okay, fine. So suppose we are writing a function for sum. Okay, for add to add two numbers. Okay, so def sorry, not this is Python thing. Okay, so int add, and data type I am declaring int stick p. Okay, so this time you can see I am just writing the pointer p, uh int stick q, and int stick result. Okay, okay, so no need to this void. And here we have some variable like this. So int a equal to 10. Okay, and b equal to 20, and int sum. Okay. So now we will so inside this function. So this is also a add function. So we will receive the value. So this is pointer now. Okay. So here the value of this a is equal to 10 and b equal to 20, and we want to find out the sum of this a and b using this function. Okay. So how we can call this function, and how we can access the data, and this function is not returning any value. Okay, so we will not return any value through this function, but still we can access the our result. We can access the result, what is the total sum, by this function using the pointer. So how we can do this? So we can simply write like this. So print, so first thing, we will call this function, so add, and we will pass. Okay, so here this p is a pointer. Okay, so that will contain address. This q is also a pointer of type integer data. Okay, and this res is also a pointer. So all these parameters are pointer in this function. So what we can do, we can pass the address to this function. This time we are not passing the this value 10 20 to the function. This time we will pass the address of the variable a, b, and sum. Okay, so we can simply pass the address. How we can pass? So and symbol a. Okay, so this is the address of a, and similarly and symbol b. Okay, and symbol this re, this sum. Okay, now this is the function we have called. Now we can write the print statement. So print f, and we will print the sum. So percentage d, and what value we have at the sum. So sum, simply. So in the previous week, if you know that we have already learned this scope things. Okay, scope things. So we cannot access the variable which is declared outside of the function. Okay, so suppose if any variable declared inside the add function, we cannot access the variable directly through the another function. So same things, if this a integer a variable is declared here, that variable cannot be accessed through inside the add function. So like this scope. Okay, so here what we are doing, uh, we are passing this, we are calling this function, we are passing the address, and we are printing the sum value. Okay, so and we are not returning anything through the function, because this function is actually void defined, and it will not return anything. So but still we will get the sum value in this variable sum. Okay, so how we can do this? So because the this is p variable, this will contain the address of a, so we can write like this. So asterisk res equal to, so now we are just accessing the value at the address at the pointer. Okay, so we will just using this dereference operation. So now this time we are using the dereference operation. So this asterisk, okay, so we can write like this. So asterisk and p, and this plus and asterisk this q. So when I'm writing this in this expression, so what happening actually, we are passing the address of a, b, and sum. Now we are reading the value from the address. Okay, so this bracket where operation will return a value of a 10. Okay, this second bracket will return a value of b 20. Now the sum 10 plus 20 will be assigned to the address of this res. Okay, this pointer, and that address is actually referring to the sum variable. So if we are updating any data on the address, so that we can directly access through the variable. Okay, so when we run this, so you can see we are getting 30 without return any value from the function, but we are directly accessing the value as a sum inside the main function variable.
Sir, please repeat again.
Huh. So let me just explain here. So what actually inside the function, so this inside the function we have the function name add, and we have defined some variable like int p, that int p, and int q, and int res. Okay, all these are pointer. So that means this p is a pointer, and this q is a pointer, and this res is a pointer, and that pointer contain the address of another variable. Okay, that address we are passing through the main function. So that a contain 10, b contain 20, and that's some variable. So we have this some variable defined integer type. Okay, so when we are calling this function, so add and end symbol a. Okay, so and end symbol b, this will be and end symbol sum. So like this. So that means we are passing the address of a. So that address is actually assigned. So suppose some this a is pointing to some memory location, that is this is contained 10, b is pointing to another
Sir,
20.
what is sum here?
Sum is a very simple variable, integer variable.
And we get the result there.
Yes, we are getting the result inside the sum variable.
Okay, okay.
Okay, this is just declared, but we have not initialized any value. Okay, so suppose this memory location which is assigned to a, so that suppose this is the address of 1002, and this address is 1004, and this address is like 2004. Okay, so suppose this is the address of this memory location where the 10, 20, and this data is stored. Now we are passing this address to the function when we are calling this. So and a, so and a, this address 1002 will be assigned here. Okay, to p. This is a pointer. Okay, so all these are the pointer, and this 1004 will be stored here, and this 2004 will be stored here. And actually this 1002 is now pointing to the same memory location. This 1004 is pointing to this location, and this 2004 is pointing to this location. Okay, so memory is same, because we are just working with the address, but memory locations are actually same. Now inside the function, when we are writing this asterisk res, so that means equal to, so that means we are pointing to this address. So this address is like this. Okay, this address, So we want to store some data at this location. So this memory location which is assigned to some, this 2004. And when we are writing this asterisk p, okay, so that means we are reading the data from this p address. So p address is 1002, and that address is actually contains the data 10. So this 10 will be written here, okay, by this plus asterisk q. So this q contains this 1004 address, and we are reading the value which is stored at this address 1004. So this is 20. So plus 20. So now this 10 plus 20, 30. 30 will be assigned to the address which is stored inside this res, okay. So res address is 2004. So this 30 value will be stored is this location, so 30, okay. Now when we are just printing here, this printing this percentile d using this sum. So now sum is just a pointing to the same memory location. So we have updated the data at this location. Now you can directly access this data using the variable name sum. So we are getting the answer sum 30 using this. Okay. So we are directly working on the memory locations. Okay, we or the address, using the address of the memory locations. Okay, without using the variable name, we have the address of the memory locations, and we are updating the data at that memory locations. We are accessing the data from the memory locations directly. So using the pointer, we can direct manipulate the things on the memory locations. So in this manner, sometimes this type of code we need to write if your function is not returning anything. Without suppose if you are not using pointer, you cannot without returning, you cannot give the output to this main function. Okay, where from we are calling without return statement. But here we are using the common same memory location, so we are updating the memory location data. That memory location we can access through the main function also. So this is the example of this pointer one. Okay, same things. One problem, very basic. I think that is also a question of graded programming assignment of this week. So suppose if you are given two variable, so like int a equal to 10, int b equal to 20. Okay, so can you swap the value of this a and b? Okay, so same thing. Suppose if I just write this swap, I'm changing the function name swap. Okay, and I'm getting like this. This is the only function requirement, and we are calling this function swap. And in next line, just print the a and b again. Okay, a and b. Like this. Okay, so into this. So now this is the structure of the question. So you need to write a swap function where we are passing the address of a or address of b. Okay, and you need to swap the value of a and b. So that means when we print this a and b value again in this main function, then a should print 20 and b should print 10. So how we can do this? So we can use the pointer things, address things here, and we can swap the value using the pointer, because we are passing the address of a and address of b into this function. Now we can just read the data from the address, and we can swap the value inside the swap function. So how we can do? We can define like this. So temp one in temporary variable we will declare here. So int temp. Okay, so this is the temporary variable. We will read the value of one variable. Okay, one memory location. So how we can read this, like asterisk p. So now we are reading the value of a. So a value is actually passed to p pointer, b value is passed to q pointer. Okay, so that we can access the value of a using the p pointer. So here we are reading this p pointer value 10 and assigning to temp variable, simple integer variable. Okay, and what we can do now, we have just stored our a value. Now we cannot lose this value because this is stored inside the temp. Now we can just change the value of at this location pointer p. Okay, so asterisk p equal to asterisk q. Okay, so what value is stored inside the q pointer? So that is actually 20. That 20 value will be assigned to the location of p. Okay, now we have changed the value of p. Now in the next line, because now p value is updated, but we have already stored the p value inside the temp variable, so we can now read the temp variable again and store to the q pointer. So asterisk q equal to s, not no need to asterisk because temp is a simple variable. Okay, so we can write simple temp like this. Okay, so now you can see we have updated the value at memory locations. Okay, directly at the memory locations we have swapped the value. Now if we have updated the value at the memory location, so if we access that memory location, so our reflection will be visible through the main function also. So when we run this, you can see now a value is when first line, this is the first print statement, this is coming 20. Okay, and this is second print statement b, when we are printing b, this is now 10. So value is swapped at the memory locations through the function. Okay, so in this manner we can directly work with the memory locations, and we can access the data, and we can update the data also using the memory address. So this is just representation how we can declare the pointer, how we can, after declaration, how we can read the address of normal variable, how we can assign the that address to the pointer, and how we can access the data from the address. Okay, memory locations. So these are the common things you should know to work with the pointer. Okay, declaration, assignment, assign address, access data. Okay, these are the things. Okay, so is this clear, this example swap and previous example, how we are just working with the memory location? Any query in this? Okay, so this is basic about the this pointer. This should be, you should know, but we will also discuss more details of the about the pointers regarding how we can perform the arithmetic operations with the pointer. So that type of things, how we can assign the address of array or strings or function. So in detail we will also learn in the next weeks, but this week just basic of the pointer, so how we can declare, how we can simply use. So that type of basic things are there. So any doubt in this? So because this pointer topic is very important in C, and this pointer we are only using inside the C. Okay, so other language we are not using this because this is not secured. Okay, so because we here we are directly working with the address of the memory. So this is also dangerous for working. Maybe someone can access the memory location which is not allocated to your program. So because of that, other programming language like Python, Java, C++, no, not C++, but that is actually not using this pointer. That is using the different things reference. So yeah, this is the one part. Another things which is discussed in the lecture is this. Yeah, this is also one topic. Storage format. Yeah, storage format. So how our data is actually stored in the memory. So uh, there are two types of representation actually we used some our systems may use to represent store the data into the memory. So here some details is given, like this decimal value is 1234. Okay, so this is at one decimal value 1234. This is decimal, and this is the binary representation of this, and this is the hex representation of this. Okay, same. So because any decimal value, if we are representing using the binary, so binary number is not uh, easy to understand. So in general, regarding this address or data storage, we also use the hex number system. And binary to hex is actually conversion is very easy. You can simply take 4 bits and you can directly map to the corresponding value in hex. Because in hex the value is start from 0 and the last value is f. Okay, 0 1 2 3 4 5 6 7 8 9, and then after 9 a b c d e f. So this 0 and this is represent to 15. 0 to 15 range. Okay, so these are the digits actually assigned in the hexadecimal system. So if you have binary number, any binary number, you can just read the 4 bits and you can directly map to the hexadecimal symbol. Okay, so this is represent to 2, this is represent to d. Okay, this 0100 is actually 4, so this is directly represent to 4. So in this manner we can directly represent to the hex. So now the things is how this data is actually stored inside the memory. So there are two types of storage format actually used to store the data. So first thing is like similar this left to right tape like. Okay, so this is representing a memory things. Okay, this 0 1 2, this is like a memory address or locations. So here you can see that the address value is small and this right side address value is great big. Okay, so that means this is the smaller value and this is the larger value. And if our data is stored into the left to right manner, okay, so that means this value, so 04d2, so 04d2, so this is actually a uh, suppose this is store this one location contains 2 byte. Okay, so this is only this is 1 byte. Okay, so yeah, this is 1 byte. Okay, this is 1 byte. And this is the another byte. So here because each have 4 bits, so 4 bit contains the total 8 bit. 8 bit means 1 byte. So in memory locations each index is representing to store the 1 byte. Okay, so that means two uh, digit of the hex 04. So if our data, so this data is storing in this manner, so that means the first value is storing to the lower index or lower address, and second value is storing to the next higher address, so left to right manner. Okay, so that is called as a big endian. So or this is also represented through this top down manner, so this vertically memory locations. So when we just represent the memory location, so this memory locations is lower address is actually we generally used as the below, and higher address we use as the top. So two types of representation our system may use to store the data: bottom to top or top to bottom. Okay, so either bottom to top side and top to bottom side. So based on this, this is called as a endianness. So how we are just storing the data. So bottom to top means, so here we have this two digit 0, 4 and D2. So 0 4 bottom to top means, so 0 4 will come at the top first, so 0 4, and D2 will come at the lower side. Okay, this in this manner. So this is top to bottom. So the first byte is actually coming at the top, and the D2 second byte will come at the lower address. But bottom to top is actually, if we will store this 04 at the lower memory address, so 04 like at this position, and D2 this at this position. So this is bottom to top side. Okay, so in this manner we can define our storage structure. So that term is actually used endianness. So big endian, if our data is stored like this, bottom to top side. Okay, so bottom to top means we can also say that left to right. Okay, left to right, that means lower in memory address to greater memory address. So that is called as a big endian. So our end is actually happening at the big address. So because of that big endian, we are using this storage type. Okay, so and next is little endian. So that means we are starting from the higher memory address and we are finishing to the lower memory address, top to the top to bottom side. Okay, top to bottom, or we can say that right to left. So this is called as a little endian storage type. So this structure is given. So the same data here, data is given like this. So suppose we have this data 1 2 3 4 5 6 7 8 4 bytes. So how this data will be stored into the memory? So you can see the same data. This is the first byte. This is second byte. This is third byte. This is fourth byte. 4 byte. Okay. So now first in big endian. Big endian. So this mem 0. Actually, this is the lower address. This is the lower address and this is the higher address in our memory. So lower in big endian, so we will start from the lower address and we will start storing this 12 at this lower address first. Okay, so this 12 is coming at the lower address. Then next value will come at the next address. Okay, in this manner, and our last value is coming at the higher address. But in little endian, so this is the reverse. Okay, so now you can see this 12 is coming at the high address. So this is now high. So you can see this is the 3 we are using high address and this is the low. So now this 12 is coming at the high address, then lower address 34 is coming at the lower address, then in this manner. So our so this is called as a little endian memory storage. So in most this 86 processor system, this actually generally using little endian, but older machine actually use the big endian. So there are different type of system actually are using the different types of storage mechanism, but our actually compiler will handle so how that data is actually stored and how we can access the data. So that is actually mapped with the our indexing. Okay, so we can access correctly. So this is the one things, and this addressing is already discussed. Type typecasting is also one topic. Okay, so stack and heap. Okay, so one more main topic is also there, stack and heap. This is also related to the memory representation. So when we use the stack and when we use the heap thing, so some basic idea is given here. So this will also discuss later. So stack things uh, in our overall memory actually. Okay, so when we are just writing some program and we are running some program, so if we are creating some normal functions, so each function is actually assigned some memory location to the function. So you can see here in this suppose we are writing the main functions. Okay, so one memory is allocated to the main function, so that stack
Sir,
we call.
what is typecasting?
Hmm? Sorry.
Typecasting.
Yeah, typecasting is just simply we are converting the data type. Suppose if we have some value in the float and we want to read as a integer, so that means we are just changing the type of some value. So I'll just take some example and I'll let you know. So typecasting simply we are changing the type of the value. So this regarding this stack and heap, basically in our memories. So some memory is allocated to the each function. Okay, when we create another function, so another stack memory is allocated to the another function. So like in the next figure you can see, so this part is actually assigned to the main function. So all variable inside the function will be stored inside this memory block. So all the variable which we are using inside the main function, so that all variable will be stored, all data will be stored in this block. If we are creating the another function in our program, so another stack of memory will allocate it to that function. So in this manner, so this memory block will be assigned to the each function. So this is actually called as a stack memory, and this is allocated for the each function. So once our function is completed, okay, so when we call the function, our function runs, and then function returns some data, and after that our memory will be deallocated. So but what is the heap here? So heap is also a different types of memory for the program, so that actually contain the data, and which is actually global. So if you want to access some data, access some variables throughout the whole program, okay, so suppose like a global variable. So global variable, it can be accessed through inside the any function. So suppose if we have declared the global variable outside of the function, then we can access that variable uh, through the any function from the code. Okay, so that means that variables can be accessed in any part of the program. So that actually is stored in different memory location, and the address is also different. So that actually keep remains during the life of the program. Okay, during the life of the program, that data is stored in the this memory, different memory locations. So that is actually called as a heap. Okay, but this stack which is assigned to the function. So function means the variable which we are declaring inside the function, that is actually local for that function. Okay, if we have completed the function, so that memory blocks will also be removed, deleted. Okay, and we cannot also access the one function variables into the another function variables. Okay, another function. So that memory is allocated different way, so that is called as a stack. But for common variables which are using by the each function or inside the code from anywhere, so that is like as a global variable, static variables, so dynamic memory allocation. So this these things we will understand later. So dynamic memory in week 9 maybe. So these are actually common variable which can be accessed throughout the program. So that is stored in the different memory place, so that is called as a heap. And this if we have declared this type of variable, that will remain saved during the life of the program, but this stack may be removed if function is completed. So regarding the typecasting, okay, so typecasting, suppose I have one variable a equal to, suppose this is a float a equal to, like this is 3.14. So now this is a float variable. Now I want to store this data to the int variable, like so int a, sorry, int, this is already used, b equal to. So what we can do, we can change the type of the value of the this 3.14. So I can write like this. So int typecast. So this is the typecast, and I can write like this a. Okay. Now when I print this b, b. So now this is a simple 3. So here we are just reading the some value which is actually have a different data type, and we are printing differently. Okay, so we are storing this value after typecasting. So here we are changing the type of the value of a. Okay, so in the integer format. and assigning to the integer variable now. Or then we can access that variable b. So there you will get only three data here. So in this manner, we can convert the data types. So if some can take some other example, like, so let's discuss in the lecture. So this is actually code discussed in the lecture. So you can also see this Replit link is given in the portal itself. So you can also just play around this code. Okay. So this is demo ptr cast pointer cast, and this is the function. Okay. And before this, we have another thing. So this Indian things we can also see this, because this is also important for the assignments questions. So this second function actually, okay. So what we are doing, we are just reading the data. This integer a variable, it contains the integer value. So this is actually a hexa representation, okay. And we are storing this value inside the integer variable, okay. And this 0x means this is the hex value, okay. And 1 2 3 4 5 6 and 7 8, okay. And this integer actually a 4 byte, okay. Now we are just changing type, we are using the type casting things, okay. This is the pointer casting which we are using here. So what we are doing, we are using this address, okay. We are reading the address of a, which is actually defined for the integer variable a. Now we are changing this address into the character, because character contains only 1 byte, okay. Integer contains 4 bytes. And when we are assigning, so this char c, so this c is a pointer of the data type char, okay, which that will contain only one byte data, okay. And before that, we are converting this type casting. So we are reading the address, okay. And we are converting that address into the char. So after conversion this, so this data will be convert into the char type, and we can access this data according to the byte wise. So 1 byte will contain 12, and second byte will contain 34, third byte will contain 56, and fourth byte will contain 78. So, and here you can see that we are printing the address of a uh, in the unsigned long manner. But after that, we are just reading the char, okay. So this char, then this, hmm. Okay, yeah, this is the strings we are printing here. So this percentile d, percentile lu, okay, and this percentile 2x. So we are printing this percentile d from this I variable, okay. So we are printing the I loop, we are running the loop, because now the data is stored into the character form. So characters data we can access through the index. So that index, we are running the loop 0 to 4, less than 4, okay. So 0 1 2 3. So we have only 4 value for I. And what is the value at this place ci, okay. And no, this is the address. Here we are printing this and symbol, so that means this is the address in integer format, unsigned long, and this is the value at that address. So you can see in the output this char 0. This char 0 means this is simple I value. But when we are printing this lu, so that lu means the address of this first byte, okay. After converting this pointer into the this integer pointer into the character pointer. So this is the address. So you can see the address now. The address of a was this. You can see the last digit only 2092. So this is the starting point of this address a, okay. Now we, you know that integer actually contain the 4 byte. Now we have just break this 4 byte into 1 byte into the char data char pointer. So now you can see that the first address of the first character at this 0 is actually 92, okay. Next character contain the next address 93. Okay, this is the next byte, and this is 94, 95, and this 92 byte contain the 78. Okay, so 78 data. So yeah, so this machine is actually use the little endian format. Okay, so little endian format means uh, the last value is, you can see 78 is storing to the lower address. Okay, so that means first value is starting from the higher and last value is storing at the lower address, so higher to lower. So this is called as a little endian. So this machine is actually using this little endian storage data type. So and we are printing this into the same format, little endian. Okay, so 0 to 4. So 78 is printing first. Okay, last value, because we are printing using 0, 1, 2, so lower to higher side. So 78, then 56 is stored at this byte. Okay, 93, 34 is stored at 94. This 12 is stored at 95. Okay, so you can simply type use the pointer typecast. Okay, so pointer typecast means you have a pointer, you have an address of integer variable, but you can also change to the character pointer. So character pointer will contain the only one byte, because the character size is 1 byte. Okay, so that means it will break into the that integer address will be break into 4 bytes when you're converting into the character. So then you can directly access the data using the each byte, like this, using the for loop. So this is actually a pointer typecasting. So you can access the data if you have given any big integer value, how you can access the each byte value. Okay, so in this manner you can access the break of the part of the value, like this. So these are some of the same similar examples. Some a value is given b, then how we are using this typecast. Same things we are converting into the this b value, so which is a hexadecimal stored inside the integer variable, but we are same converting into a character data types. So you can just run this code and you can understand how this type is actually changing, and see the lecture also. So professor have also discussed this code in lecture. So then you will get how we can also convert based on the need. Okay, but this is the later things. But you can, so the first things you should know how we, what is the pointer things, and how we can use the pointer, how we can declare, how we can assign the address to the pointer. These are the basic things which are required to understand first. Once these are clear, then you can move to the later things. So the other part is actually theoretical part, so discussed in the lecture. So that is actually, you can watch the video, and if any problem you found, that you can discuss in Friday and Saturday session. Okay, so these are the main topics. So assignment is also based on the similar lines. If you see the assignment of this Week-6, so PPSA 1. So simply copy the value of variable b into a using the pointer. Okay, we are copying the value. Okay, here. So like code is given. Complete the following program to defining an integer pointer that point to a variable a. Then copy the value of variable b into a using pointer. Okay, so simply read the value using the pointer and paste into the copy to the variable a address. So using the pointer, simply copy the value. So practice PPA2 is also same things. We are asking to write a function. So I have already declared this. Add. This is similar to the add function. We are passing two variable, and we are getting the solution. Okay. So calculates. You need to write the calculate sum, and here we are passing the a and b value. We are passing b value, but you need to write store the result at pointer. Okay, which we are printing in the output here. So this is, I have already explained, and this Okay, this is something new. Huh. So let me just discuss this thing. So this is related to the array little bit. So here actually we have declared the one data structure array, which actually will be explained into the next week in detail. But to store the strings, actually, strings means we want to store some like word or some sentence. So actually we have to declare this type of data structure to store that strings. So here this is given as a prefix or suffix code. So now what you need to do, so here what we are passing inside the function. So this is actually a function get char you need to write, and we are passing the address of first character. Okay, here input is given, that input actually contains the strings, and we are passing the address of first character. This is the address of first character, and we are asking the second character or like third character. This, so here example is given. So this is the string a b c d e f, and one k value is given. So k value means if k equal to 2, that means you need to return the second character from the left. Okay, so if you know the address of first character, then you can simply add one value to the address. One value means 1 byte, so that will move to the next locations. So next location, then you can access the second character from the next location. If you add one more byte, then you can access the third location in this manner. So the output is given. So here hello is the input. So in function, address of h is given. So second element you need to find out, the just add one more, so you will reach at the second character location, so you can return this answer e. So this is very simple. So here code is given, address is given, simply add the one address and just access the value. So how many address you need to add, how many bytes you need to add, you have to define based on the value k value. Okay, what k or n value is given in the function. So inside it is defined as a n. So, and we will discuss these problems in the live session. Okay, Friday and Saturday. But before that, you should also try. So now this is the question. Based on the reading this pointer typecasting, okay, which I just declared, how you can read the integer value and how you can convert like this. So how you can read that simple, this is unsigned int. So this is simple typecasting. So here you are printing as a unsigned int first, then signed int first. So just try to this, and pp5 is based on this big endian things. So this is directly you can go through this code which is given in the lecture. This one. Okay. So these are the topics actually. If anyone have any question now, you can ask. Or any other questions? Yeah. Now, so in the next week, you have OPP exam. Okay. So in OPP exam, just prepare yourself for the OPP exam. So first two questions will be based on some error. Okay. So we will just explain that what will be the type of OPP. Okay. Later. So anyone have any query, you can ask.
How many questions are there in OPP?
4,
Timings?
2 hours.
Okay, all are programs, na sir?
Yeah, all are programs, but I think first two questions will be based on the correction of the code. Okay, so maybe some syntax error or logical error will be there in the solution code. Solution code will also be there, but you have to just correct the code. You have to figure out the syntax error or logical error in the code and just correct the code. So first two questions will be based on that. Okay, so when you are writing the code, just also check if you miss the semicolon, if you miss the bracket, so what type of error is comes. So just also think about the syntax things. Okay.
Sir, for final exam, I have to qualify in OPP 1.
Uh, no, you can attend the final exam. I have to check the grading document. Otherwise, you have to for final grade to passing this course, you have to qualify the one OPP at least,
Okay, okay,
and you have to score at least 40 marks in one of the OPP exam.
okay, sir.
Okay. Okay. Then any other query?
Sir, in grade week 5,
Hmm.
practice assignment 9, question number 9, please, sir.
Hmm. Okay. Okay. So B5 PP
Week
practice
5,
assignment 9.
practice assignment 9.
Eight, 9. This one?
Yes, sir. You have discussed, but
No.
again, plus.
Okay, so in this function, we are asking that the correct order in which the function are return or exit. Okay, in the above code is. So return means when the function is completed and when function is returned. So what is the order of the based on the return or exit? Okay, of the function call. So when we run this code, which function is actually called first? That main function, correct?
Yes, sir.
So main function by default call first. So I'm just writing the sequence of main function, calling function. Okay. So
Okay.
this is the main function. We'll call first, and inside the main function, when you are entering inside the main function, so next function is this print function.
Yes, sir.
Okay. So when your code is running, this first line will execute first, but this is a simple expression. And second function is printf function. Okay. So this is the next function which will be called. I'm writing the called sequence. Okay. So this is the print function. And when you are calling this print function, inside this you are calling this next function. So add 5a, correct? So that means next function will be called add5a. Okay.
Okay.
So now this is the next call. After that, so this is the next things. Then this next print function will be called. Okay, print f, this next function, and after that this next function inc will call. So this is the calling sequence, how the function is actually calling. But question is asking about the return, which function
Return.
will return the value first. Okay. So
Yes,
in
sir.
this case, when we are entering the main function, so this is the first call, but main function is not completed yet. Okay, so first line is executed. Second line, when it is executing, so print statement is actually calling this first, and this print statement is still not completed. Okay. Then we will enter inside the print parameters, and this parameter is also a function. So this function will be called. Now when we are calling this function, so our control will be moved to this function add 5, correct?
Okay.
Okay, now this function will execute, and this function is now returning something. Okay, so you
Okay.
can see now this is the first function which is returning something, add 5.
Yes, sir.
In the execution add 5, this is the function which is returning some value x plus 5, and this x plus 5 will be passed to the here. Okay, this print statement. Now this value is completed, you have received some value, and that will be print. Okay, so this statement will print in the output some things. So that means now next function is completed, this print. Okay, after getting the value from the add 5 return statement, this print function will complete and will print something in the output screen. So that means this print statement is performing next. Okay, now this print statement is completed. Now
Yes, sir.
you will move to the next print call. So this is the call, and when you are moving to this call, inside this as a parameter, next you are calling also another function. So that is new function. So this in C is a new function and it is calling to the function. So this function now will execute, and inside this return statement will execute. So now this is completed. So that means this is now completed next in C. And when this is completed, it is returning something to the same function, and that value will be print into the output. So that means the second print statement is now completed. Okay, and next is the return statement of the main function. So that means the main function is now completed last. So this is the sequence where the function is actually completing. So add 5, print inc, print main, B option.
Yes, sir.
Okay, so in this manner the call is happening and the function is actually execution. Okay, this is okay.
Yes, sir. Next is 10. You have told garbage value.
Hmm.
Sir, please repeat once again garbage. Hmm.
Okay. Okay, so here add function is given, gyro is given. Okay, so I think these things we can understand through the compiler. So let's I'm declaring some variable like int a equal to 10 and b equal to 20 and z c. And here we are calling some functions like int add p. What code is given? Add function. Okay, add function is void function. Int percentile. Okay, so this is the equivalent code of the program. So if you see, uh, we have written this int a equal to 10. We have assigned some value 10 into the a. So b equal to 20, and that means we have declared the variable b and we have also assigned the value at that memory b. But c is declared, but there is no value assigned to this c. Okay, so
Okay, okay.
that means by default at that memory locations, if we have not assigned any value, that means the previous any random value, we can say that a random value. Okay, that will be there at, if we have not initialized anything. Okay, so if we are if we want to access some memory locations, okay, we have declared only and we have not updated the data at that place. So by default some random data is actually located at that place. So that random data will so in this code you can see when we are calling this function add a b. So this is a simple void function. Void means its function is not returning anything. But here
Yes.
actually when we are declaring this int c, okay, so this c is actually pointing to the different memory location. So this C is actually not equivalent to this C. Both are
Oh,
different because this C variable is actually local variable for only add function, and this C is pointing to the different memory location. And the lower C, this main function C, is a different variable that is actually contain the different memory location. So both are actually different here. Okay,
okay, okay, okay,
and
sir.
we have not assigned any value. So if we are printing this C into the function main function, so that means this will not update, and by default some garbage value will come. You can see this value is coming.
Okay,
Okay, when we run this, so you can see the different memory is allocated now. In the different run, you will get the different data. Now if we assign like C equal to 1, then you can see only one will be printed. So now the some random data which was stored at that place that we have not updated. So that random data is actually called as a garbage value. Okay,
okay,
and
sir.
here both variable are actually different variable and local for the only function. So this C is only for the accessible only the main add function, and this C only accessible inside the main function. So if you are updating C here, so this will not reflect for this C. Both are different.
Oh, okay,
Okay, because of that we have discussed this pointer. So how we can actually access the data uh, which is updated inside the function. So we can update the memory location using the pointer, then we can access through the same variable. So suppose if we pass the like if we can pass simply this thing. So pointer one, so int pointer and C.
see,
Okay, now we can simply write this asterisk, and inside this function we pass the address of C. So add C. Now you can see we will get the solution 30. Now we are updating the value at the address memory locations. So now this address is actually the same which is assigned to the C.
okay, sir.
Okay, so that random value which is not updated for our program, that is actually called as a garbage value. Okay, any
Okay,
other
sir.
in this? Okay, any other query?
Sir, what is the system of OPP exam?
The system of the OPP exam is actually you will get some mail regarding that, and one system compatibility test will also conduct before the OPP exam. So where you have to uh, you will get the same environment where similar to the OPP exam. So in the OPP exam, actually you have to connect through your phone or system. So similar to your course portal link, okay, one new links will be given to you, and that link will be activated only during the OPP exam time. Okay, and then that links you can access on your computer, and you have also joined through the Google Meet or Zoom through your phone. And camera, your phone camera will be open, that so proctor can see you and your system.
Okay.
Okay, proctor will monitor to you by looking through your camera, mobile camera.
Oh,
So
okay.
you will simply open that link, and you can access the questions during the exams, but proctor will monitor to you by the camera.
By from my phone.
Yeah, your phone camera. Okay,
Okay.
so you have
Okay.
to set up your mobile camera in that way, so you and your system should be visible.
Oh,
Okay, so
okay.
in this manner this is proctored exam, so cannot do anything. Okay, okay.
Okay, sir.
Hmm. Okay, any other query? Okay, okay, then thanks, we will meet on Friday.